Cuda example is taken from the SDK. I simply added additional C++ files to illustrate some points of discussion. I also added another CU files as well. So it turns out there are now two CU files and two C++ files. And this one is the makefile that came with the SDK, and I added a new makefile that is aware of Parasoft instrumentation. There is really no need to isolate CU from CPP. Um, However, in common practice, there are benefits of isolating the pure CUDA from the pure C++ for reasons of portability. For example, if the project can run without GPU, so the kernels are implemented in the CPU, it will be a much slower version of the function, but still it will run. And then if the software is compiled with CUDA because the system has CUDA GPU, then you can just make a switch, then the function will switch to the CUDA version. This is what happens in one of the dlib face recognition project. That consists of thousands of files, but actually, if we look at the statistics here, 97% is C++, but only 0.7% of this is CUDA. So the rest is a massive C++. And I remember this one has only like around less than 10 CUDA files. Somewhere here they are located, but the rest are C++. So this library can be compiled even without a GPU. So the kernel functions, the super fast CUDA functions, find your equivalent with a CPU implementation. It will be very much slower, but at least it will run. Then if you compile this library in an environment with a GPU, then you can just add a switch and then it will use the CUDA equivalent implementation. So you can see that is now the benefits of isolating CUDA from C++ for portability purposes. And as a side effect of that, CUDA project can be analyzed because they are C++ code. A small portion is only in the CUDA code, so the rest is pure C++. They can be statically analyzed with any popular static analyzers. First, let us try to build this project with its own makefile. So I will try make. Before that, let me open the entry point, which is this, where the main is located. So this is the main, and then let's go up, and this is C++. However, if we go up here and here, so now this line at line 154 is the triple enclosure. The open and the close triple enclosure is a CUDA specific notation. C++ does not have this kind of encoding. I will move a little bit up here, and okay, that's still and here the global, for example, this variable is suddenly here, but it is nowhere to be found in a C++ system. Does not exist. Only in CUDA software is this global have meaning. Cool. Also, this block dim variable cannot find this anywhere in C++. CUDA provide this entities. So now, after seeing that this file is containing CUDA constructs, everything therefore becomes CUDA. Okay. The distinction at this point of time in the computer compiler when a symbol exists in a file, the rest becomes everything is CUDA. So you cannot treat this as okay, this is C++, and then suddenly this one is CUDA. They belong to the same file. Everything is CUDA now. So it is at a unit of compilation unit, okay, file level. Go to the C++. Okay, let's look at the C++ one. Okay, now these are the pure C++, and interestingly, the contents here make calls to the CUDA. For example, see, there's a call to ping device, and this ping device is implemented in CUDA. So a pure C++ code can call to CUDA and vice versa. CUDA can call to C++. So they talk at that level. Okay, and then so that's it. And now I'll build the project originally without instrumentation, without CUDA. I mean, without Google Test. So I will use the default makefile. So if I'll just type make, by default, it implies this makefile. It will produce an executable, and you can see that when we run the executable, we must have this environment runtime path defined, and that executable is this one, copy in BTX. So if we run that, okay, actually we need to, like that, we need to run this executable with this variable defined, and now we have some output. So this whole execution is it's just a check of the CUDA profiling tool interface, which is what is meant by COPT, CUDA profiling tools interface. It makes calls to some APIs in profiling tools of CUDA. And okay, so I'll do a make clean, and then I'll run again, this time with Google Test. So there is a target here called, because we have a Google Test here in this directory. And the Google Test only calls to the addNum function, which I added. And if we go to the addNum function, this is the addNum function, which I put a CUDA kernel call. So these are the changes that I did to have a sense of things calling each other to get complete story. Okay, so the Google Test calls addNum, and we call ping device. And if we look at ping device in the Cuda CU file, ping device is implemented as a CUDA, and this is one of the smallest example call of a CUDA. You can see the tripole enclosure here. Okay, ping kernel. So it's not irrelevant what this exactly is this doing, but the point here is that this one produces a machine code that goes down to the device, okay, the device, which is the GPU kernel, because the CPU is called the host, and the GPU is called the device. So okay, yeah. So everything from here is a stub, by the way, since obviously this is still part here is still in the CPU, but then as soon as it encounters this kernel call invocation is when the execution reroutes to the GPU, and this whole thing here, the stub will wait, the CPU will wait, and then when the GPU completes, the CPU will resume. So it's sort of heterogeneous execution between two engines, the CPU and the GPU. Okay, so okay, this is a Google test. Let me run this. Make uh, test adnum. Of course, Google test is just at the software level. It is let us run the Google test, and this is the we can recognize from the output. It is indeed Google test, and I put some printf into the CUDA to prove that the call indeed went there. So ping cu that 1010 because inside the ping.cu I put a printf, and these are the line number and the file. So this is the file, and this is the line number. This is the line number. So these are well-known preprocessor macro to identify the current file and the current line. Yeah. It's just a shortcut. So we have Google test. Google test can call to CUDA, of course. Now let's do a clean. Now here, from here on, I will invoke the makefile.conf because a while ago it was using the makefile because when you type makefile is the default, and this time I will specify makefile.conf. First, let us take a look at the content of makefile.conf, and this is where the Parasoft CT is brought to the picture. Okay, it's been brought to the scene to instrument the entire compilation. So let's use this now. So make minus f. Okay, so I specified I tell make to use this makefile.conf now, and I press enter. So it will be compile an instrumented build, and it's linking to the CUDA, and this is the output. Okay, so right now if we type there is no coverage log yet, but then if I run this instrumented binary, this one, uh, to run that we can just again prefix it with this one. So this is the instrumented binary, and this is the necessary environment variable that needs to be, the runtime needs this, and I will press enter. Okay, so we run the same executable, but it is instrumented. As a result of this instrumented execution, if we type clog file, and now Parasoft generated coverage log. This is the result of the instrumentation, capturing all the what's happened during the execution. And then I generate a report from that clog file. I'll type make report 2. Okay, so now we have an HTML. So we open the report, HTML, and look and behold, only the C++ files uh, went, uh, went here. CU files are not instrumented, as I said. Okay, let me see. Okay, so let me do a clean. Now, I also have a Google test here. Make file test. Yep. test. So this is also an instrumented Google test, and it run the Google test and then generate a report, report 3, and then we also have this report, but this report is from the Google test alone. So the Google test is this one. Okay, these are the Google tests. So we are instrumenting the Google test, and then our source code is here, 100% coverage. So take note that it also makes calls into the CUDA ping device, and we can see the output of that when we uh, run. You can see here the Google test also invoke the CUDA code.